Good morning, good afternoon, everyone, and welcome in from across the continent for another super exciting Exploring by the Seat of Your Pants broadcast. For those of you joining us for the first time, which is most of you today, we are all about bringing conservation, adventure, and science into classrooms around the world with like 30 live free interactive broadcasts every single month. Everything we do goes to our YouTube channel, and you can check out the programs we've done this year, in the last 10 years. We've been live from the North Pole. We've been live with baby sloths. We've been live with some of the coolest scientists and explorers on planet Earth this month alone. Now, I'm so excited to dive in with today's topic, which of course you guys are all here for. But I want to note before we get underway, we do have a Kahoot today. So between our talk and our Q&A, if you want to play along with a little 4-question quiz to test your understanding and have some fun, you can pull up that game pin on a separate tab, and we'll get to that in about 25 minutes. But of course, the reason the horde of you are here, the 870 of you from 17 states and 3 provinces are here, is because today, for the first time ever, we are going live from a baseball diamond to talk with Bronson Balholm about the physics of baseball. About 2 months ago, my wife and I were watching an amazing Party Animals versus Savannah Bananas game in banana ball, which is the coolest sport in the history of the world ever. And Bronson comes up to bat, and the announcer says, "Bronson's awesome, and he also teaches kids about STEM." So I called up Bronson, and we said, "Hey, would you want to come on?" And we're so happy he said yes, and you guys are so happy he said yes, because we get to introduce all his awesome stuff to all of you today. So a big welcome in to our huge new audience, and without further ado, you're not here to hear from me, you're here to hear from Bronny. So Bronny, welcome to the broadcast, man. So nice to have you.
Hello. How's everybody doing today? Hi, guys. My name is Bronson Balholm, and you guys can call me Bronny, or in Banana Land, where we're at right now, I'm known as Hollywood. But today, guys, I'm going to be talking about baseball, STEM, and engineering on the diamond. And this is a little bit of a special one. I don't know if you guys can see, but I have my cameraman right back here, Chris Sachi, showing around. We are at practice today, everybody. This is a very, very special day. We are here in Savannah, Georgia, at Grayson Stadium, which is home of the Savannah Bananas, the Party Animals, which is the team I play for, the Firefighters, and the Texas Tailgaters, the 4 teams of banana ball. So we all practice here, and right now we're getting ready for our championship series that's coming up. So we're in playoff mode, and I wanted to get you guys a little bit of some STEM talk today while we're going through baseball practice today. So I'm going to bring you guys around, meet some new players, have some fun activities, a couple surprises, but I'm ready to have some fun. You guys ready to have some fun? Yeah?
So much fun.
Let's get into it, baby. So first, I want to talk a little bit about me. Like I said, my name is Bronson Balholm, or you guys can call me Bronny. I am from Los Angeles, California, and I studied aerospace engineering and played baseball at Arizona State University, home of the Sun Devils. So there, I was able to learn a lot about aerospace engineering and physics and how they apply into baseball. Funny story, when I was in high school, I had a coach that talked to me about physics and baseball and how they work together. That's where I found my love for engineering. So if I can get you guys thinking a little bit about STEM while you're this age, before I was even in high school, you guys might know STEM better than I will. So let's get right into it. Now, you guys might be asking, how can STEM be in baseball? Well, STEM is actually in every single walk of our lives. The moment that we move, the moment that we do anything, energy into something, it's all STEM. So I want to break it down first for you guys real quick. What is STEM? STEM is an acronym. STEM stands for science, technology, engineering, and mathematics. And I'm going to go over each part of these and how they apply into baseball. Now, one of the things that we're going to talk about first is science and physics. Now, if you guys have ever thrown something, a ball for example, you've seen that the ball goes through the air. Now, as the air is going around the ball, there are forces that we're going to talk about. So Jesse, would you mind putting that first slide up for me real quick? Some forces that affect the baseball.
We've got it.
Up there? Good. Okay. Now everybody can see this. I want you guys to imagine that this baseball, I've thrown it over there. As this ball is traveling through, there's air that's going around the top of it, underneath it, and around it at all angles. So you see that air coming off in that picture, right? So there's 3 forces that I want you guys to remember that affect the baseball when it's in the air. The first one is the one that we all deal with. And I'm thinking you guys can kind of guess, right? It's gravity. Yes. Gravity is what pulls us all down. The weight of gravity keeps us in the center of the earth. So every object that's in the air has gravity pulling it down. The second one I want to talk about is the air that's coming around the sides of it. This is called drag. Drag is what slows it down horizontally coming off this axis on the side. And now the last one I want you guys to think about, and this one's a tough one, is lift. Now lift is when the air is coming underneath the ball and pushing up. So you have three different forces. You got lift, you got drag, and you got gravity. And ultimately, the ball will fall because of those forces. That sound good? Okay. So that is the first part of science. As you see, there's forces that are put into any sort of baseball that we throw. Now, I hope that there's some ball players out there or people that have watched baseball or banana ball. There's a lot of things that we do in baseball and sports that are a part of physical elements. So this word I'm going to talk to you guys about is momentum. Now, a pitcher is the person that's on the mound throwing to the catcher. And I don't know if you guys can see it, but that mound is that little hill right up there. And so I'm the catcher that's catching the pitcher. And in order for the pitcher to throw the ball or a hitter to make a swing, he has to do something called momentum. Momentum. Now, one way that a pitcher can create momentum is through what we call a windup. Now, I'm sure you guys might have seen something like this before, but it looks like this. I'm no pitcher, but I will demonstrate to you guys. As you go, that actually, hey, can I get one of your help real quick to just demonstrate a windup to some of these young kids out here? Guys, this is my pitcher, Jake Lealios right here. If you could go through a windup. You go back.
Where do you want me facing?
That's all good. You can imagine that you're going that way. Yep. Back, up. Good. Excellent. So, can I have you do it one more time and just slow it down? Jake Lealios is one of the hardest throwers here on the Party Animals. Now, that first step, could you go back? So right here, stop, thank you. He is building up momentum by going behind the baseball. Now, go into the next one where you pick up the leg, hold it. Now, he's gathering that momentum at the top. Go through that next one to the stride and hold it. Yes, good. See, now he's brought his body through and he's holding that ball back still. And the last part, go and follow through. Beautiful. See, that leg swings through right at the end, and that's what's called momentum. Thank you so much, Jake. Appreciate you, my brother. Okay. All right. You guys will see some more players coming on in soon. But so that is what we like to call momentum. Now I'm going to bring the whiteboard right back up here because we can actually calculate momentum. Now, if you guys stick with me, momentum, we denote this as the letter P. And that's what we like to call a variable. So momentum is equal to mass times velocity. Now, mass, as you guys might know, mass is the measurement of a weight of an object. So think of a baseball, not very heavy. Think of a very big boulder, a very large mass, very heavy. Now, velocity is a term that we usually say for the speed of an object. So I want you guys to think about momentum in real life. Now, imagine a big boulder and a small golf ball. As that big boulder is moving towards the golf ball, it's going to hit the golf ball and shoot that golf ball, right? That's the act of transferring energy, which is the definition of momentum, the act of transferring energy. So think about that. That big mass that has maybe a small velocity is a big boulder coming through, and as it hits a small mass with no velocity, the big boulder is going to change that energy into the golf ball and shoot it further. So those are some physical aspects that I want you guys to kind of look at. Everyone sticking with me? Everyone all good?
We are so good, Bronny. So good.
Good, good. Jesse, would you mind hitting that next slide for me?
Absolutely. Let's bring it up. Right
on. Good. So we're going to stick with pitching before we get into hitting, because pitching is some of the most interesting physical aspects. Now, has anybody heard of some types of pitches before, right? There's the fastball, which is one that everyone throws. It's a straight ball, and it comes right off your fingers. Now, the next one that I want to talk to you guys about is a curveball. So I'm going to get down right here. I'm going to try to explain to you guys how a curveball works before we go see it in action. So instead of being straight on the seams, a curveball is going to be slightly on the side of it. Now, as the action of a pitcher throwing, he's going to be turning the ball on top. So now, imagine with me, guys. This ball is turning at this top spin, like it says in the picture. There's wind that is going with the ball now because it is turning with top spin. But remember those forces in that picture we talked about earlier. As the ball is going through the air, there's wind that's going against it in the opposite direction. So that's one of the laws of physics I want to talk to you guys about. It's every action has an equal and opposite reaction. So if this ball is turning this way and tumbling, it has wind pushing against it the other way. Now, as you guys can see in the picture, those wind patterns are going to cross right at the top. And so the air pressure, the difference in air pressure that when those winds connect is what causes the ball then to drop and fall. So does a curveball actually curve? Yes, it does. But the reason that it actually falls down is the wind forces right behind it. And that is something that we like to call aerodynamics, which is another fancy word for wind forces. Alrighty, guys. I think that this might be just the perfect time. I think I got my pitchers down there ready to go. Let's go for a walk, guys. Let's go check out Grayson Stadium right now. Come along. Welcome on in. Might see some people along the way. It's a beautiful day. And this is just what we do on a regular basis. We come out here, we practice our hitting, our pitching, we're working on our plays, making sure that we got trick plays coming down. It is just the most fun job in the world, and I'm so happy you guys are here to experience it with me. We're going to be going down to the pitchers now and checking them out. As they're throwing, there's a lot of different times that they have to throw different pitches. Like I said, there's the fastball, there's the curveball, and we're going to go talk with one of my pitchers, Brett Helton, aka the Lion, we like to call him, and he's going to demonstrate a bunch of pitches that we like to call. You got some guys throwing balls out here. See that ball? It's cutting right through. It's beating gravity. It's got lift behind it. It's got a little bit of everything. All right. Well, hello. Hello, my beautiful pitchers. You don't have to. We're party animals. We are out here in the sun practicing. It's a beautiful day. Today, I am with my good friend, Brett Helton, number 10. He is my pitcher. Say hi to all the kids out there.
Hi, kids. What's that?
So, would you mind helping us demonstrate some different pitches to these guys?
What? You are? I got to throw you like 4 things real fast.
Can we demonstrate some pitches real quick to you?
So, you caught me at the perfect time.
Perfect.
I just did my long toss. I'm doing my in progression, trying to do my pull downs, getting that zip on the ball, trying to backspin it. Now, I've thrown 3 fastballs. All my fastballs are 4 seams. I go across the tracks that way. For some reason, with the way my fingers and arm slot works, my 4 seam has more tail than my 2 seam, so I only throw 4 seams. With all 4 seams going, you get that white ball look where you can't see spin, you can't see the laces. So I try and get maximum revolutions, all 4 spinning, and I throw it every single time I throw a fastball because it moves more, goes faster, all the above.
Would you mind showing that first one, and then we'll go to the next one?
Now, when I'm doing my progressions in, I like to be fluid. When I'm on the mound, fluidity is the most important thing for me. So when I'm doing my flat ground, I always have my feet moving. I'm always doing a shuffle. So it's kind of like I'm still long tossing a little bit, but it keeps me fluid and it keeps me moving.
Right back here. See this fastball right back here. Yeah. See that? It's rotating right on this axis right here. So it goes straight, and if anything, it's going to go a little bit up. Nice.
I make sure that my feet are moving. I'm nice and fluid. The ball's getting out of my glove early, and everything's timed up naturally. There's no set, pick, pause, all this stuff. It's just fluid and natural, what my body wants to do. Fastball.
Creating momentum. Nice. Would you mind showing another pitch, maybe a changeup or a curveball, or even nice pick, Brett? Look at that, right on the field.
Now we're going changeup.
Changeup.
I go middle finger, ring finger, right at the bottom of the horseshoe. When I throw this, I try and have an extra loose arm. I lead with this finger, and I try and completely pronate across. I try and get, even though it's not really possible, I try and produce top spin with it so my changeup can dive like this to the right. I know it's not possible, but having it in your head, I like having a loose arm. When I come across, I lead with this finger, and I pronate completely over with a loose wrist.
So that ball should be rotating this way, so we want it to go down and away.
So again, I'll have loose feet, athletic feet, loose arm, and I'm going to extra pronate over the top of this changeup, and hopefully you'll see it dive a little bit to the right.
Mm-hmm. Nice, nice. See that last second it kind of dips away? That's the wind forces pushing against it.
Do it again.
Another
Tell
one.
your guy you're throwing a changeup, same thing, same grip, over the top.
Mm-hmm. That's a good one right there. The ball just dives right at the end, and that's that wind.
Trajectory out of my hand that's a little bit up might make him tense a little bit, and then it immediately drops like that.
Mm-hmm.
I'm going right to my cutter.
Cutter.
Same thing as my four seam, but I offset it and I put my fingers together. Now, when I'm throwing this cutter, I'm leading with this finger, and I'm giving it just a little bit of that.
Mm-hmm.
So that way I can get this revolutions to where it can catch right there and go a little bit left. I don't want to wrap it like a slider. I want to just throw a fastball, and I want to just at the very end give that middle finger a little touch.
Mm-hmm.
My curveball, I'm going to come completely over the top, and I want it to pop. My slider, I want to wrap, but my cutter, I want that fastball, and I want just a little bit of push at the end with that lead finger.
So this ball is just going to have a little bit of rotation to it to the side.
Give your boy cutter. Here we go.
Nice, nice. So a cutter is similar to a fastball, but it's that last second, it's going to move just a little bit that way to the right.
Cutter.
Cutter. Woo! Wow, that was nasty. What else you got?
You got that heater look. It comes out the exact same, looks the same to the hitter, and the tunnel looks just like this. My heater's supposed to go a little bit to the right. My cutter's supposed to go a little bit to the left. So that way I can throw the same pitch in the same spot whenever I want. 2 different ones, right and left. Now I'm going to drop the curveball in there. This is Uncle Charlie. Good old Uncle Chuck. I go down the train tracks here towards the horseshoe. I got my knuckle up. So I've got that tall one. I put a lot of pressure right here. And when I rip this down, I throw it as hard as I can, and I try and squeeze. And I want that thing to pop.
So
I want it to look completely different than my other pitches. I want it to pop up, ton of revolutions. I want it to go down. The reason I do that, if you want to have a wipeout curveball, you want it to look the same in tunnel vision. I don't have a wipeout curveball, so I want it to look so different that it looks different than my slider, looks different than my cutter, looks different than my fastball. I want something that's I can throw 0-0 for a perfect go-ahead pitch that looks completely different. I want it with one strike, so if they've seen all my pitches, I want to throw something different. Mm-hmm. I don't have a wipeout curveball. You don't have to, because I use this pitch for effect and not for a strikeout. So we'll see it.
Come on, right behind. Show them behind right there. So it's that curveball we talked about right on top. Nice. See?
And when it comes up, it's big, loopy, it's really slow and down. If you want to have a wipeout curveball, it needs to be about 10 or 12 miles per hour less than your fastball. Mine's like 20 miles per hour less, but I use it for that effect. I want it to be slow. I want it to look funny. I want them to not swing, get a free strike.
Nice. So like we talked about with that curveball, when he threw that, he was coming across it on top, and that's that wind that's pushing it down.
Get it again. Curveball.
Curveball. Old Uncle Charlie. Wow. Sorry, I just blew into the mic, but that thing caught some wind and went all the way down right there. Nice.
First shot type. So now I'm going to the slider. I'm going to give it to him. Now I go in between the railroads right here. I put a lot of pressure on that middle finger, and I really wrap. So cutter, just a push, no wrap. Curveball, completely different. My slider, I want to grab right there. I want to rip it with this. I want to throw it as hard as I can, and I want to really snap that wrist at the end so I can throw it in the zone, out of the zone, having that action. This wants to look like my fastball, come into the zone and out of the zone, and that way this is the only strikeout breaking ball that I have. This is the best one.
Mm-hmm.
Slider.
Nice. So as you guys saw, with the curveball, we were coming on this axis right over the top, right? Slider is coming a little bit more horizontal. And so, like I talked about, every action has an equal opposite reaction. So that wind is pushing against it and pushing it down away.
One thing you can probably think of too with the difference between curveball and slider, when I'm going curveball, I kind of want my wrist stacked straight. So when I throw it, the ball can pop straight out, go up and come down.
So you want that revolution.
When I'm with my slider, I really want to think about getting my lead fingers as close to the catcher as I can. So curveball, stacked wrist, straight up and down. I want my slider to act like a fastball. And when I'm at the end, I want to really reach with those lead fingers so I can come around it and I can create that spin that goes down. So completely different. We'll go slider one more time. You can see it. The last one was pretty good of being in the zone, out of the zone. I threw it down to the left, a little skip to him. For effect, that's exactly what I wanted. I want it to look, come out like a fastball, and dive really hard right to left.
Slider. Yes. See that last second, and boom, it was coming across. So
Very cool.
That is one thing. When he talks about revolutions, and this is the coolest thing, baseball players are talking about physics all the time without even knowing. Revolutions means how many times does the ball turn around. And so he's trying to get that last second release where if he gives it an angle where it's coming off this finger, the middle finger to last, that means that it's rotating along that axis, which is the way that it rotates around. So I think you got you want to do that one more time, or you want to show the special one that we like to show off, the one that defies physics.
Special one.
Ball?
Special one.
So Brett throws the most pitches out of any pitcher on the team, I think, in the organization. But he throws a knuckleball, which, if you guys have seen, defies the laws of physics because it has barely no spin. Show him how it's done.
I throw it just like R.A. Dickey. I get my two fingers up. Only pressure's here on the ring finger. Pinky's completely off. Thumb is natural. When I throw it, I want to throw it with my palm facing home plate. I really want to focus on this part of my hand going towards the catcher's mitt. When I throw it, I give a little bit of push at the end. So normally I've got my backspin on my fastball, just pushing it really hard, trying to get it through the zone as fast as I can. This one, I kind of get to the end. I face the catcher's mitt with that palm, and I push right at the end, and I try and take all the spin off. I'm coming at you like this with a fastball. Big rotations, big spin, loose wrist, lots of rotations. This one I'm trying to come just like that, push, and take all the spin off of it so it goes like this. That way, the air can catch all the seams. It can go right, it can go left, it can go up, it can go down, knuckleball, whatever it is. Both directions are the good ones. We'll check out a few of these.
To be honest, a lot of the times it's got a mind of its own. So I'm going to be the one catching these couple ones real quick. The other pitchers didn't want to catch the knuckleball. I don't know if you guys will be able to hear Brett, but go ahead, Brett. Woo! That is crazy. See that ball? It's moving so much. It's because, and Brett's probably talking to you guys, but I'll talk over him. It's the wind. It's the wind, guys. Aerodynamic forces.
Barney's coming back with the mic so we can hear Brett, the lion.
Nice. Yeah. Real quick, if you want to say what you just said, because I know they're going to hear you.
So with that one, I want my fastball to be about 3,000 RPMs, just like that. That
revolutions per minute.
About 500, because it did have a little tumble, but it had the left to right action down. It's probably about 500 down and left. If you could get something to zero, it's the perfect knuckleball. Very hard to do, but it's attainable. Now, just for fun, what I do with all my pitches, I throw all of them normal, natural arm slot, and I throw all of them again submarine. It's not as good, it's not effective. I'm not a natural submarine pitcher, but having a different look, having an arsenal that you can throw from every arm angle, sidearm, regular slot, over the top, 3/4, submarine, it just gives a new look to the hitters. If you can throw it for a strike, having every single arm angle is a big time weapon. You can mess with timing, you can mess with windows, you can mess with tunneling. All those things play a big part.
Lots.
And so I just drop down, I go to the side. If I feel comfortable and I can throw a strike at any angle, I'm going to do it. Once again, for effect. It's not the best pitch I got. It's not a pitch that's going to strike them out. But the effect of changing their window, because the hitter's going to be sitting there staring at where he thinks the ball is going to come out of your window of your arm slot. So if he's used to that, 3 or 4 pitches in, seeing the same spot, where you release the ball, and all of a sudden you drop down, his entire window, his approach, his timing, it's all out of whack just because he can't time up that window that you have. And then he goes, boom, you can get a free strike. So I threw everything everywhere. Confidence is high. You throw a strike with any pitch. Gangster.
Thank you, brother. Thank you for demonstrating that. See, we are talking about physics, and we don't even know it sometimes because we're ball players and we know physics. All righty. Thank you so much, Bizzle. All right, guys. Now, that's the pitchers. They're going to let them get their work in real quick. How cool was that? I hope you guys enjoyed that as much as I did, because it really is a little hint into the mind of pitchers. You heard Brett. He was talking about a lot of different terms that I hadn't even mentioned yet. You know, revolutions. That's how many times the ball is spinning. When he's talking about axis and he's trying to throw it off that last finger, right? So that's creating angles. And now, actually, this is a perfect demonstration. Actually, I want to talk to you guys real quick about angles. So when you're throwing a ball, how many of you guys have ever thrown it right in the air and it doesn't go very far, but it went really high, right? So, or how many of you guys have thrown something very low and it doesn't go very far? It hits the ground, right? So you're trying to find the perfect angle that you can throw a baseball to make it go as high and as far as possible. Now, I want to show you guys real quick. Let's make a right angle with our arms, right? This is 90 degrees. Everyone go ahead and make a right angle. So if this is 0 degrees, right? This is 90 degrees. Now, if we want to find that perfect angle that we can throw the ball as far and as high as possible, cut this 90-degree angle in half to 45 degrees. And that is the angle that we want to have if we're going to throw the ball as far and as high as possible. Cool, guys? Nice. All righty, let's keep on going. So that was pitching, throwing. We talked about momentum, talking about science. We were talking about how many different aspects of STEM is in baseball. And so this is absolutely awesome. Thank you, Brett, so much for helping to do that. But now we're going to go talk about hitting. And real quick, Jesse, would you mind hitting that next slide for me real quick?
Absolutely.
A picture of building a bat.
We'll build a bat together. Let's do this thing.
But this is the little thing I want to talk to you guys about engineering, because there's so much engineering that goes into every single part of any sport. There's engineering going in for the bats. There's engineering for the balls. There's engineering for, the gloves. Just everything has engineering to it. And I think that it's really interesting how much that people put a lot of time in, these companies like Louisville Slugger, to making the best bat that they can. So we're going to talk about some hitting real quick. Oh, hold up, everybody. Hold up. We got a special guest coming on in. It's
what?
Farty, the Party Animals mascot. Everyone say hi. Yeah, Farty, what's going on? Yes. Thank you so much for being here. So I'm so glad that you are here today, Farty, because today we're talking about baseball and STEM, and we're talking all these kids out here. I want to tell them a little bit about the physics of Farty, because Farty defies all laws of physics. It's unbelievable. First of all, he is the ultimate party animal. And if you take a good look at him, would you mind just rotating just a little bit to the side? His center of mass is all spread out. It's all spread out all around. So he's got to be able to hold himself back so he doesn't tip on over, because he's got a lot going on. And now the second thing that defies the laws of physics of Farty is that his farts, and I don't know if you guys know this, his farts don't smell like normal farts. His farts smell like cupcakes. Vanilla cupcakes, actually, if you can believe that. It's unbelievable. And oh, there he goes. Is that a hint of vanilla frosting? Oh my gosh. guys, it's his farts don't smell like anything other farts. He breaks every single laws of physics. He's absolutely the best guy we've got. And I think that we should do some dancing real quick. Hey, Troy, hey, Brent, would you mind helping me out real quick? Jake, would you mind helping me out with some dancing real quick? We're going to do a little hey baby for everyone. Everyone get on up at home. Come on. So we're going to do our signal our signature dance that we do here. Hope you guys can see everyone. We got Jake Lealios, you guys met him earlier, pitcher. Brett Helton, pitcher. Troy Banks, catcher, pitcher and catcher. And our mascot, Farty. Guys, let's go ahead and lead him through real quick. Little hey baby. Just do it. Let's do it the first time to show him how we do it. Hands up. And we're going to go, hey baby. Woo. I want to. Reggie, get in here. If you'll be my girl. Come on, Reggie, get on in here. Come on, guys. Hey, baby. I want to know if you'll be my girl. Everybody at home, one more time. Everybody, here we go. Hey, I want to know if you'll be my girl. Hey, thank you guys so much. Thank you guys. Appreciate y'all. Yo, seriously. Thank you so much. I appreciate you, Farty. Thank you, Troy. Wow. Look at that. I hope you guys are all dancing with us. That was a whole lot of fun. Thank you so much for being here, Farty. I really appreciate you guys. He is the absolute best. Give me a hug. I love you. I don't know if you guys heard that. Again, now I smell like cupcakes. Defies all laws of physics, Farty. My absolute man. Thank you. Thank you. All right. Now, that was a whole lot of fun, guys. But all right, let's get back to business. So we talked about pitching, talked about angles of throwing a baseball. Now I want to talk to you guys about hitting. And hitting is some of the most fun things that we like to do as hitters. Every single day, we'll come out here, try to be perfect with our hitting. But there are some ways that I can show you guys that make it easier to be the best hitter that you can. So first thing I want to talk to you guys about is finding the sweet spot on the baseball bat. Now, every single bat has a different sweet spot. And especially it might be a little bit somewhere different. Might be a little bit towards the end, might be a little bit towards the middle. And the way to find that is by taking your hands on top of the barrel. You hold it at the top like this, very light. And what you're going to do is you're going to tap. I'm going to try to get you guys to hear this. But see, I tap it at the middle. It doesn't sound great. I tap it at the bottom. It doesn't sound great. So what I'm trying to find is where I don't feel any vibration at the top when I hit the bat. And I'm trying to find the most sound spot. So you guys can also do this. If you're at home, feel it around, not there. Oh, right there. So that is the sweet spot. I'm not sure if you guys can hear this. Let's hear it. Oh, that was loud and pure. So what we will do with our bats, we will mark X on the sweet spot because that's the spot that we're trying to hit the ball every single time. Baseball is a game of such small details where if you miss a ball just a little bit, it might be an out. So that's something I want to show you guys is the sweet spot. How about I'll show you guys real quick. I got a little tee set up over here real quick. Let me show you guys what a sweet spot sounds like. Let's get a couple swings. It's my first swings of the day, guys, so don't go too hard on it.
Yeah.
We'll go righty first. Oh, heads up. Good? We're good? Okay. See? Now that was right in your living room. That was a righty swing, right? And now I'm a switch hitter, so I'm gonna gotta do it from the other side. And now, that was the sweet spot of the barrel right there, right? Here we go. Oh! And my cameraman caught it. Look at that. Right there. So, ladies and gentlemen, that is the sweet spot on the bat. We're trying to hit it right there every single time. Now, I talked about angles and throwing. Angles and hitting is a different object. So, say you're hitting, and if you hit a ball, if this is 0 degrees, let's go back to that right angle that we talked about, right? 90 degrees, 0 degrees. So, say that you hit the ball and it's going down below the 0 degrees. That's going to be negative degrees, right? And that's going to result in a ground ball. Yeah. So, if we're trying to get a base hit, ground balls aren't going to work it all the time. So, when we're trying to hit and say we miss a little bit up and the ball goes up to about, let's say 50 degrees or higher, that's what's called a pop-up. And that's really easy to catch. That's an out. So we're trying to find that perfect sweet spot of 10 to 30 degrees where it's a perfect line drive and you have a more likely statistic to get a base hit. So that is right there in action. Your sights, you're trying to get it right on the sweet spot. Your angles are trying to be perfect, and it's tough. You know, baseball is such a game of little details, like I said. So if you're not perfect right on that barrel, you miss a little bit in on the barrel, a little bit out on the barrel, a little bit up, a little bit down, it's not going to work out. But that's all baseball. Let's go back on over to the whiteboard. Are y'all sticking with me? Y'all good? I hope so.
We're all good. We've been loving this. This is fantastic.
Yeah, I love it. We're getting close. So stick with me, y'all. Can I get that one more slide, Jesse, please? Should be some temperature and baseballs, if I believe correctly. Yeah?
You got it.
Good. Perfect. So let's talk about matter, right? There's 3 phases of matter. We have a solid, right? This is a solid, this is a solid. We have a liquid, which would be water or any sort of, liquid. And then we have gas. I hope you guys can all see that on the PowerPoint. So we have those 3 phases. Now, I want you guys to think about in terms of heat and coldness. Think of a solid as an ice cube. It's cold, right? Think of water. It's it's a little bit warmer than an ice cube because it's moving around. And the gas is the warmest of them all because it's moving around. Now, I want you guys to think a little bit deeper with me and think about what I like to call atoms. And everything that we see is made up of atoms or particles or molecules that we like to talk about. So think about the ice cube. And I know you guys can see the picture. Those atoms in the ice cube are all close together because it's cold. They don't have a lot of move. They don't have a lot of room to go, right? The water, they look at the atoms in the water. They're a little bit more loosey-goosey. It's a little bit warmer, and it's easier because there's a little bit more room for the atoms to go. Now look at the gas. The gas is all spread out because it's the warmest out of them all. It's the hottest. It's moving around, moving fast. It's got a lot of room to go. So now, when I talk to you guys with this question, will a hot ball or a cold ball travel further? I hope y'all's answer is a hot ball, because if you look at those atoms, they're moving around. They're moving around, right? A cold ball won't travel as far because they're all condensed next to each other. You want that warm, warm, warm ball. That's why growing up and playing ball in the sun is the best. The ball travels further. So summertime is the best time. But stick with me, guys. Again, just towards the end, I want to talk to you guys. So we've covered a lot. We've covered science. I talked about the technology and engineering of bats and balls. Now we're going to talk about mathematics. We're going to talk about statistics in sports. Now, the first thing I want to talk to you guys about is batting average and how we like BA. So batting average is how we determine how well a batter hits. Basically, how many times do they get a single, a double, a triple, or a home run out of the times that they come up to the plate. So in order to do so, we're going to take number of hits divided by number of at-bats. So here, I'll give you an example real quick. John got 3 hits in his 6 at-bats. So we take 3 hits, 6 at-bats. Hope you guys can read that. My handwriting is not great. I'm sorry. Now, think of it. 3/6. We'll just write it as 3/6. We can reduce that to 1/2, right? 1/2. Oh, that 2 is not looking good. I'm sorry. 1/2. And now, in baseball, we like to use decimals a lot. So we can take this and turn this into what we like to call 0.500. So we'd say that John would be hitting 500. And that means for every 2 at-bats, he comes up to the plate, he's going to get at least 1 hit. And that is very good. That is unlike anything in baseball. To give you guys an example, the leader of batting average in our league in banana ball is Jake School, and he's hitting 371.
Ooh.
So
Good.
that means that, I heard you, Jesse. That's pretty good. If you round that up to about 4, say that's 400. that would also be 4 out of 10. So that means that for every 10 times he comes up to the plate to hit, he's going to get 4 hits out of those 10 times. Think about that real quick. That means that he's failing 6 other times. He's not getting a hit. He's either hitting it right at somebody or he's getting out some other way. So that's one thing I'll talk to you guys about later. But baseball and engineering go hand in hand because failure is how we have to keep coming back up and keep learning. So that is batting average. Next one we're going to talk about is earned run average, or as we like to call it, ERA. Now, ERA is what we use to determine how many runs a pitcher gives up in his innings of pitching. So in order to calculate that, I want you guys to stick with me because this is a little bit harder. So we're going to take the number of runs allowed and you're going to multiply that by 9 because 9 is the number of innings in a game. And from there, we're going to divide that number that we get from the amount of innings that the person pitched. So for example, we're going to say Sean allowed 7 runs in 34 innings pitched. So if he gave up 7 runs in 34 innings, we're going to take this number 7, we're going to multiply it by 9 because 9 is the number of innings in a game. So that's going to give us 63. And now from there, we're going to take that and divide it by the number of innings he pitched. So 63 divided by 34, and that is going to give us 1.85 as Sean's ERA. Now, that is a dang good ERA.
Yeah.
And if you were to put this into terms, I would say you round this up to 2 to make it easier. So think about that. That means that Sean, if he pitched 9 innings, he would give up 2 runs.
Yeah.
That's what we use to estimate how good or not so good a hitter or a pitcher might be using the earned run average and the batting average. And one thing I want to touch on is that the record for earned run average that we have is 1.69.
Woo!
So that is very good. And that is by Ben Dunn on the Firefighters. So that means he's averaging 1.69 runs in his 9 innings that he would pitch. So those are some things I talk about because stats in baseball can tell you a lot about players and can tell you a lot about who they are and how to pitch to them, what type of hitter and pitcher they might be. So stats, they help us out. And I think that it is very, very helpful to know it's very, very helpful to know how well a pitcher might be doing, or how well a hitter might be doing. So we'll do this all the time. We'll check out, is a hitter hot right now? What's his batting average been in the last month? What was it in the first couple months? You know, see their trends. ERA, you can see how well a pitcher is doing. So STEM is all out everywhere in baseball. You've seen the science, and we talked about the ball and the ball going through the air. We're talking about the bats and engineering behind it, and then the mathematics with all the stats that we do. So there's STEM everywhere. You guys got to meet some players, you got to dance, you got to meet Farty, the only one that broke the laws of physics. But that is what I like to say. Jesse, would you mind going to the next slide? Should be the last slide real quick.
One final note.
Just say a word. Yeah? All right. I want you all to say this word with me. Persistence. Persistence. Trying something even when it is very, very hard. And trying and trying and trying again. That is persistence. I wouldn't be where I'm at right now on the ball field if it wasn't for persistence. There's a lot of times when I grew up and I wasn't the best player, I had to keep coming, I had to keep working, I had to keep getting better, and persistence is what kept me going. Now, fast forward it to the other side of the engineering field in college, we used to say that failure is learning. Failure is progression. Because in engineering, you go to project and maybe it didn't go out the right way, but you learn from it, and then you have persistence to keep coming back, to keep trying, to keep going at it, to find that answer. Because again, failure is not the end. You keep learning from it, you keep getting better, and you keep pushing. So that was one thing I wanted to talk to you guys about. Persistence, persistence, persistence. I want to be where I'm at. None of us will be where we're at if it wasn't for persistence, and you guys can have it too. It's all in the mind. So persistence. And then second thing I want to touch on is catch kindness, something I preach about everywhere I go to. And I try to tell everyone about it because it's my personal brand and it's something that means a whole lot to me. As a catcher, a whole part of my thing is to make sure that my team works well and that we all work well together. And the best way I found to do that is by catching kindness and passing on to the next person. And this even started when I was younger. You know, I grew up and I remember maybe some of you guys, like, it's tough. It can be tough as a kid, and growing up, it's not easy. So catching kindness is all about taking that moment and looking in for your compassion, being empathetic, and going out and looking out for other people around you. One way that you guys can do this is real easy. When you go to recess today, go find somebody you haven't ate lunch with. You know, don't be afraid to go up to them, introduce yourself, and be kind and be a friend to them. And then when it comes to recess, you know, don't be afraid to go up to somebody new and ask them if, hey, you guys want to join our game? Do you want to play something together? You know, it's those little acts of kindness that you catch and you pass them on to the next person that I promise will make you feel so good in your heart, and it will even double when you're giving it out. So catch kindness, pass it on to the next person. Really means a whole lot to me that you guys hear that. Keep on being kind. And then the last thing, thank your teachers. You know, your teachers are heroes. And I can't stress this enough because I wouldn't be where I'm at if it weren't for my teachers. They have brought me so much help and made me the person I am today because they've always been there. And I still keep in touch with some of my teachers today. I still talk to my physics teacher from high school who inspired me to get into physics. And coaches too. Coaches, your parents, all these people, thank them. Tell them how much that you appreciate them, because I promise you, your teachers will love it, and it absolutely means the world to them. So thank your teachers, and that's all I've got. But thank you guys so much. I really hope that you guys enjoyed this. That's Baseball STEM Engineering on the Diamond with Bronson Balholm. Thank you guys so much. Love y'all. Let's get into some fun.
Let's get into some fun. Ronnie, we did so many firsts in the history of exploring by the seat of your pants in this broadcast, and it's just been such a special ride. We've got about 12 minutes left together. I know some of our kids have to go off to other classes pretty soon, but what we're going to start with is a Kahoot. That 4 questions to test your understanding, have some fun, and what you win for the Kahoot is Bronny and I's everlasting respect. So no pressure at all. We'd love to have you participate wherever you're coming in from. There's almost 100 of you already in. We're going to do our 4 questions together, and then we are going to go live for 1 question per class. If you have extra questions, please do email them to us after the broadcast is done. We'd love to pass them along to Bronny and get you some cool baseball answers. But let's dive in. The physics of baseball in 3, 2, 1. Drum roll, please. Quiz. What banana ball team does Bronson play for? We met several players. We met the mascot. We met everyone. Cover the shirt. Savannah Bananas, Party Animals, Texas Tailgaters, or the Firefighters. What do we think? Get those answers in. The faster you answer, the more points you get. Let's do it. 7 seconds, 6 seconds, 5, 4, 3, 2. This is our biggest Kahoot of the year, by the way. Way to go, guys. You guys rock. Oh, Party Animals. We are in banana ball. So we talked about the Savannah Bananas, but the Party Animals are where Bronson is at. Lucky Owl has our lead. Way to go, man. All right. Question 2, multi-select. There's more than one right answer here. Might be 2, might be all 4. Let's check it out. What are the forces affecting a baseball? Lift, electromagnetic, gravity, or drag? More than one. What do we think? By the way, I love it. You guys are the best YouTube audience I've had in years, and I do this 30 times a month. You are so much fun. Thank you for being such a great crew on YouTube and on StreamYard. You absolutely rock.
Ooh, shout out
Right.
YouTube.
Yes, our answers are 1, 3, and 4. Way to go. Most of you got that right. Oh, funky coral. Complete change in our leaderboard. Okay, question 3. What angle was the best distance with a throw at the same speed? Is it 20? Is it 45? Is it 60? Is it 90? Where's that ball going? If 90 straight up, zeros like this, what angle should our ball be at? Let's see. Here we go. 7 more seconds, and we got 1 more. Miss Raines' class. We're coming to you first in Q&A. John T. Tuck right after that, and then Miss Still's 4th graders. Ooh! All over the place, but 45 is our correct answer. Way to go. You guys are an amazing group. I love it. Clever Turtle takes our lead. Our leaderboard is crazy. All right. What was Bronson's final note? We talked about catching kindness. It's very important. Was it about sheer physical strength, sweet dance moves, having a bigger glove than everyone else? That helps in baseball. Or persistence? I hope you all get this. I want 100% right. The more you practice, the more you try, you can start off in a bad way. And if you work hard at it, you can accomplish anything. It's one of the big messages of baseball and everything we feature at Exploring by the Seat of Your Pants. Yes, persistence is correct. All right, let's see our leaderboard, Bronny. And then we're going to Miss Range's third graders in West Virginia. Funky Lion is third. Second is Luminous Oryx. And first, for all the marbles, drum roll, please, is... Dun, 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 dun. Clever Twirtle. Way to go. Awesome, guys.
Yeah.
You are good, folks. Let us know you are in the chat. Miss Raines' class, take us away with our first question. Hey.
This is my friend Andrew. You have to read it out loud, you do.
Hey, Andrew.
Hold on.
Hi,
Now,
Andrew.
you can or you've seen.
And Miss Raines, could you repeat that for us? It was a little quiet.
What is the fastest? What is the fastest pitch you can throw or that you've seen thrown?
Ooh, great question. As a catcher, I have caught some very fast throwers, and I pride myself in throwing the ball very hard. So the hardest I've ever thrown is 94 miles per hour, and that was a couple years ago. The hardest pitch I've ever caught is 103 miles per hour from my high school teammate, Hunter Green, who actually just pitched for the Reds last night against the Dodgers.
That's pretty cool. I want to stress that I'm a normal adult man and I can throw at 62 miles an hour. So that's very, very fast. So way to go. Great
question. Actually, fun fact, a ball went through my glove and hit me right in the shoulder is how hard he threw it. So.
Oh, no. Oh, we're going to head to Burlington. John T. Tuck, come on in, guys. Take us away. Hey. Hey. Hey, man, go for it.
What are the physics of a knuckle curve?
Ooh, knuckle curve.
Great question. I'm actually going to go find a baseball to help you guys demonstrate this. So, knuckle curve is a good idea for a pitch. Now, as you saw how Brett was showing out there, if you remember, he knuckled it like this. And when he threw it, he was just staying on top of it and letting the ball wiggle around, right? Because when that ball is moving through, the wind is all going around it, right? And it's pushing it all in different directions, which causes that ball to knuckle. So a knuckle curve is going to be kind of similar to almost how Brett threw his curveball. If you remember, he's going to put that finger, I'm trying to show you guys, there you go. That finger, like how it was like this, instead of both fingers, he's going to have it with one finger on top. And now, when he throws the ball, he's going to have that action. Remember when I talked about when he's coming over the top? So it's going to rotate, but that last second, this finger right here is going to push. So it's going to add a little extra movement to it. So instead of a knuckleball where it's just going to go, woo, and no idea really where it's going to go, the knuckle curve is going to have that little woo, but it's going to drop more. So it's going to have a little bit of the knuckle and the curveball to it.
Cool.
Great question.
Ronnie, so I learned my math from baseball. All the ERA, batting average stuff was right up my alley. And I've got to say, in grade 6, I had no idea what a knuckle curve was. So you're my new hero, buddy. That's awesome.
Yeah, dude, that's crazy that you knew what that is.
Cool.
That's awesome.
Yeah. Mrs. Still's class, we're going to come to you. We'll take one from YouTube, and then we'll wrap up and bring everyone in for a big thank you and farewell. Come on in, West Virginia. Hey, guys.
Hey, guys.
Fourth graders. Hello. Hi. I think your audio is being really iffy. So we're going to say hi, and you can share it in the chat, and I'll get your question in, okay? It's so nice to have you. Share it there. I'm going to share one from Boise, Idaho, Miss Smith's class, grade 6s. They want to know, does hitting the ball with the bat cause pressure to slow it down? Like, does the bat make it go faster or slower? Bit of a joint question.
Okay. Great question. I'm actually going to grab a bat here real quick. So, I just want to make sure the question was right. When the ball is coming in, when the bat makes contact, does it make it go faster or slower?
Yes.
Yeah. Good question. Great question. So, this is really cool. If you guys want to go check this out after, slow-mo video of a baseball hitting a bat is so crazy. So, the bat comes through, and when the ball hits it, it's crazy to think about, but the ball actually gets pushed into the bat a little bit, and the bat, even though it's so stiff, will have a little bit of bend to it. So these two will hit. And remember like the momentum that we talked about earlier? So this isn't very heavy. Neither is this. But when this gives a velocity and this has a velocity going the other way, they are going to redirect and go that way because this part is coming on in and this is stronger than this. Ultimately, since we're holding on to this, we are a lever that is attached to the ground. So from there, since we are established on the ground, this has nothing it's touching except for gravity. So that's the only reason that the ball is going to compress. The bat is going to have a little bit of flex bat, but since we're connected to the ground, it's going to shoot it out. Hopefully that answers your question.
That's pretty great. We're going to head back to Mrs. Still's class, see if we got the mic working. Let's see. Yeah, you share in the chat. We got a weird robotic hum with you guys.
Yeah, put it in the chat.
Enthusiasm. While we're waiting for that final question, I just want to note, if you want to check out Bronson on Instagram, he's on TikTok, he's on all social media. Check out Banana Balls. If you've never seen it, their games are on YouTube. They're so amazing. And if you want to catch us at Exploring by the Seat of Your Pants, we do 30 of these a month with people that admittedly are not as cool as Bronson and the Party Animals, but everything's on YouTube, including this one. And we'll wrap up with one final question. Phoebe wants to know, have you ever been injured while you're playing, Bronny?
Have I ever been what?
Injured.
Injured? Oh, absolutely. Are you kidding me? It's all part of the game. As a catcher, I get beat up every single game. I'll take balls off the chest. I'll take a foul ball off the mask. I've broken bones, but it's nothing that I've ever had before. You know, it's okay. I'm okay with a little broken bones because you always come back with persistence.
There you go. Persistence with broken bones. That's a new one. And also in Exploring by the Seat of Your Pants history. Bronny, this has been such a hoot, man. Thank you for your passion, your expertise, your knowledge. 870 kids from across the continent and beyond.
That's so crazy.
We are going to bring in all our live classes to join us in saying catch kindness together, okay?
Oh.
So if you're at home on YouTube and you want to scream and yell too, you can annoy the principal. You have Bronny and I's permission. We'd love to hear it. Miss Rain's class, John T. Tuck, Mrs. Still's class, Miss Thrasher's class. Thank you so much. We're going to bring you in. Catch kindness, everybody.
1, 2, 3. Catch kindness.